Welcome. In this video I'm going to show you how you can perform a post-hoc analysis after a goodness of fit test using Pairwise Goodness-of-Fit Test and Microsoft Excel together with my stikpetE add-in. My add-in is available at this link. Once you've downloaded it, you can open Excel, go for File, Options, Add-ins, and then click on Go. Click on the Browse button and then go to the downloaded file. That should give you access to my stikpetE library or add-in, and that should have a lot of additional functions then. The function of interest for now is the post-hoc pairwise goodness of fit. Sorry about that. I have all my data in column A. There are additional parameters besides the data, which should actually not be the entire column A, but just the first value all the way to the last one. You can specify which test you actually want to use, so either Pearson, Freeman-Tukey, or any of the other ones. If you don't specify expected counts, which you could if you wanted to, then it will assume each category had an equal amount of expected count. You can adjust for multiple testing using different methods, Bonferroni, CDAC, Hommel, Holm, etc. It's also optional to use a continuity correction, which is only used if you're not used if you're using a multinomial test. A modified version, which is only for Freeman-Tukey's, weight and lambda also for only these specific tests. It will return quite a lot, but it might be easier to simply show you. So here I typed in my function, I specified the range and which test I wanted. I didn't actually have to do this, but then I would otherwise default to the default version, which is actually also Pearson. It gives a lot of output. It shows every possible pair of categories. The sample size, so this for married, it's all the same, of course. And then the second category, the sample size. The observed proportion, which is simply the first one for the first category, so this one divided by the sum of these two. The expected proportion, in this case, is using 0.2, but that should actually be 0.5, so I'm going to fix that later on. Then the test statistic, the degrees of freedom, the p-value, and then the adjusted p-value depending on which method you've used for the multiple testing correction. It also shows the minimum expected count and the proportion of cells that had an expected count below 5 and the test that was actually used. Now usually you're most interested in these. If this is below 0.05, then it would be considered significant, and it's actually testing if these two might be the same in the population, and for all of them it seems not to be the case. So each category had a significantly different count than each of the other categories. So if you wanted to do a multinomial test, it actually then does a binomial test. There's no test statistic. It shows you the probability that was observed of having these two, and then the number of combinations it tested it on, the p-value and the adjusted p-value. These are completely different because, as you can see, I only selected the first 14 rows. If you have expected counts, you can enter them for each possible category, and then you can add that in as an additional parameter, and then we'll actually use those for your expected proportions. Alright, I hope this video was helpful, and thank you for watching.